This is SpaceTime Series 28, Episode 47, for broadcast on the 18th of April 2025. Coming up on SpaceTime, Hubble helps determine the rotational rate of the planet Uranus. A new crew arrives at the International Space Station. And we look at the dangers of going into space. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers using NASA's Hubble Space Telescope have made new measurements of the planet Uranus's rotational rate with 1,000 times more accuracy than previous estimates. The findings, reported in the journal Nature, were made using a new novel technique which analysed more than a decade of Hubble observations of Uranus's auroral activities. The research is important because it establishes a crucial new reference point for future planetary studies. Uranus is the seventh most distant planet from the Sun. It's a gaseous cyan-coloured ice giant, slightly larger than its sister planet Neptune. Most of Uranus is composed of water, ammonia and methane in a supercritical phase of matter which astronomers call ices or volatiles. The planet's atmosphere has a complex layered cloud structure, and it has the lowest minimum temperature in the solar system, just 49 Kelvin, that's minus 224 degrees Celsius. Uranus takes 84 Earth years to complete one orbit around the Sun. But its most notable feature has always been its axial tilt, some 82.23 degrees. In other words, it's almost rotating on its side. Even more amazing, that rotation is retrograde, the opposite way to where most of the other planets in the solar system rotate. Now, because it orbits the Sun on its side, it means that each of its poles are getting around 42 Earth years of continuous sunlight, followed by a further 42 Earth years of continuous darkness. Uranus has the third largest diameter and the fourth largest mass among the solar system's planets. Now, based on current models, inside its volatile mantle layer is a rocky core surrounded by a thick hydrogen and helium atmosphere. Trace amounts of hydrocarbons, thought to be produced through hydrolysis, and carbon monoxide, along with carbon dioxide, thought to have originated from comets, have been detected in the planet's upper atmosphere. There are many unexplained climate phenomena in Uranus's atmosphere, such as its peak wind speed of 900 kilometers an hour, variations in its polar cap, and erratic cloud formations. The planet also has very low internal heat compared to the other giant planets. The cause of this remains somewhat unclear. Determining any planet's rotational rate is challenging, especially for a world like Uranus where direct measurements simply aren't possible. So the authors developed an innovative method to track the rotational motion of Uranus's auroral activity, the spectacular light displays generated in the upper atmosphere by the influx of energetic particles near the planet's magnetic poles. This technique revealed that Uranus completes a full rotation in 17 hours, 14 minutes and 52 seconds. Now, that's 28 seconds longer than the best estimate obtained by NASA's Voyager 2 spacecraft during its flyby of the planet back in 1986. The study's lead author, Laurent Lamy from the Paris Observatory, says these new measurements not only provide an essential reference for planetary scientists, but also solves a long-standing issue: the fact that previous coordinate systems based on the outdated rotational periods quickly became inaccurate, making it impossible to track Uranus's magnetic poles over time. But with this new longitudinal system, astronomers will now be able to compare auroral observations spanning nearly 40 years, and even plan for an upcoming Uranus mission. The breakthrough was made possible thanks to Hubble's long-term monitoring of Uranus. Over more than a decade, the Hubble Space Telescope regularly observed its ultraviolet auroral missions, enabling researchers to track the position of its magnetic poles with magnetic field models. Without Hubble's continuous observations, it would have been impossible to detect the periodic signals with the level of accuracy needed. See, unlike the aurora of Earth, Jupiter or Saturn, Uranus's aurorae behave in a unique and unpredictable manner. This is due to the planet's highly tilted magnetic field, which is significantly offset from its rotational axis. The findings are not only helping astronomers better understand Uranus's magnetosphere, but they'll also help provide vital information for a future Uranus mission. The Planetary Science Decadal Survey has already prioritized a NASA-backed Uranus orbiter and probe mission for future planetary exploration. This report from NASA TV.
Uranus is the seventh planet from the Sun and the third largest planet in the solar system. It also may have the coldest interior, emitting far less heat than its counterparts Jupiter, Saturn, and Neptune. It is known as an ice giant because it contains more ices, including water, methane, and ammonia, than Jupiter or Saturn. And while NASA has learned a great deal about this planet over the last 3 decades, there's a lot more waiting to be discovered. Back in 1986, NASA's Voyager 2 spacecraft flew by Uranus, making it the first and only spacecraft to visit this distant planet. Previous observations showed that Uranus has a unique tilt of its axis, so it rotates almost on its side, causing its poles to actually face the Sun. No other planet in our solar system has this feature. In its quick sprint past Uranus, Voyager discovered 10 new moons orbiting the planet that had not been seen before, and in the decades since, even more have been found. During its encounter, Voyager also saw new faint rings and explored the complex magnetosphere. Voyager only briefly viewed the planet's 5 major moons: Ariel, Miranda, Titania, Oberon, and Umbriel. These moons have a wide variety of terrains and geological features, some of which indicate possible subsurface oceans. Small Miranda has chaotic terrain, with deep canyons and tall mountains, but is likely now frozen solid. Ariel appears to have the youngest surface, with few impact craters. While Titania has a very old surface, the lack of large craters and presence of a large canyon system may indicate ancient resurfacing. Oberon is also covered with craters and has valleys and large mountains. Umbriel's surface is the darkest of the Uranian moons, and it sports a strange polar ring. The origin of this ring is still a mystery, but scientists believe that it may have been formed by an icy impact. Since Voyager, ground-based telescopes and the Hubble Space Telescope have played the leading role in our understanding of Uranus. Since 1992, Hubble has watched the slowly changing Uranian seasons, including changes in its unusual pale blue color and polar hazes. Telescopes have also revealed that Uranus has a complex weather system with massive storms that can last for months or even years, with wind speeds over 500 miles per hour. The ongoing search for ocean worlds and life beyond Earth makes Uranus an exciting target for the James Webb Space Telescope and for future up-close exploration. New data will help scientists to understand the formation and evolution of Uranus, as well as its moons and rings, and provide clues as to whether liquid water may reside beneath their icy crusts. The fascinating properties of this planet, discovered in just the span of a few decades, reveal that unlocking mysteries here can help scientists learn even more about our solar system and our place in it.
This is SpaceTime. Still to come, a Russian Soyuz spacecraft arrives at the International Space Station with a new crew, and we look at the dangers of going into space. All that and more still to come on SpaceTime. A new crew has arrived aboard the International Space Station with a Russian Soyuz capsule successfully docking to the orbiting outpost. The Soyuz MS-27 spacecraft docked onto the Russian Prakal module's Nadir port following a fast-track rendezvous of just 3 hours, 10 minutes and 28 seconds after launching aboard a Soyuz 21A rocket from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan. The MS-27's 3 crew members of 2 Russians and an American will spend 8 months on station as part of the expedition's 72-73 crew before returning to Earth in December. During the crew's time in orbit, they'll conduct more than 200 experiments. They'll also undertake ongoing maintenance work on the station systems and carry out at least one spacewalk. Following its docking, the Soyuz MS-27 joins the Soyuz MS-26, the Dragon spacecraft Endurance, as well as the Progress MS-29 and MS-30 cargo ships as part of the space station's current complement of visiting spacecraft. This is SpaceTime. Still to come, the dangers of going into space, and later in the science report, scientists develop a meat flavour in order to make lab-grown meats more meatier. All that and more still to come on SpaceTime. We all know that space is dangerous, not just for satellites and spacecraft, but also for people. So exactly what are the dangers? To better understand how the human body changes in spaceflight, NASA and ESA have been sending people into space on long-duration missions. In low Earth orbit, the biggest change is the impact of microgravity. Because bones aren't carrying any weight and muscles don't need to work very hard, bone density lowers and muscles weaken. But there are also other changes. The human eyeball, for example, changes its shape. That affects vision. Fluids that normally occupy specific areas of the body under normal 1G conditions end up moving into other areas, meaning nausea and dizziness become a real issue for balance, and astronauts always feel as if they've got a head cold. And of course, the further away you are from Earth's atmosphere and its protective magnetospheric shield, the greater the risk of radiation. Apollo crew on deep space missions to the Moon reported seeing sudden flashes of light. It turns out these were cosmic rays penetrating their eyeballs. And all these issues and more will amplify as humans venture deeper into space, returning to the Moon on the Artemis missions, this time to stay there, and later on even longer missions to the red planet Mars and beyond. And that's probably only a decade or so away. Biological and physical sciences expert Lisa Carnell from NASA says despite more than 60 years of human spaceflight, there's still so much we still don't know.
What are the dangers of going into space? For human spaceflight, the first thing I think about is the astronauts actually strapping themselves to a rocket. And if that isn't dangerous enough, once they launch and they're out into space and deep exploration, we have to worry about radiation. Radiation is coming at them from all directions. From the sun, we have solar particles. We have galactic cosmic rays that are all over in the universe. And those cause damage to the DNA. On Earth here, we use sunscreen to protect us from DNA damage. Our astronauts are protected from the shielding that's around them in the space vehicles. We also have to worry about microgravity. So what happens there? We see a lot of bone and muscle loss in our astronauts. And so to prevent this, we actually have the astronauts exercising for hours every day. And of course, we don't want to run out of food on a space exploration mission. So we want to make sure that we have everything that the astronauts need to take with them to make sure that we can sustain them. There are many risks associated with human space exploration. NASA's been planning for these missions to make our astronauts return home safely.
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has shown that the shingles vaccine reduces the probability of dementia by up to 20%. The findings, reported in the journal Nature, are based on a large-scale Welsh study looking at people born after the 2nd of September 1933 who were eligible for a shingles vaccination. Now, these were then compared with people born before that date who weren't eligible. The study allowed researchers to compare two different groups who differed in age by just a few weeks. And when they compared new dementia diagnoses between the vaccine-eligible and the ineligible populations, they found that receiving the vaccine decreased the likelihood of being diagnosed with dementia during the 7-year follow-up study period by around a fifth, or 20%. If you're one of those people who don't like to kill animals just so you can have a tasty meal, lab-grown meat has become one of the big items on your grocery bill. And its use has come a long way in terms of looking like recognisable dishes. But some say flavour hasn't quite kept up. Now, a report in the journal Nature Communications claims Korean researchers may have solved this problem. They've developed what they're calling a meaty flavour, and it can be released by cooking the food at specific temperatures. The authors designed a temperature-responsive scaffold for the meat where a switchable flavour compound is mixed into a gelatinous base and when heated up to over 150 degrees Celsius, releases a tasty meatiness flavour. However, there is one problem. The authors haven't actually chowed down on the new meaty flavour yet. Instead, they've confirmed the flavour using an electronic nose and chemical analysis of its smell. And all that suggests the flavour profile is very similar to that of grilled beef. Chemtrail conspiracy theorists are getting desperate. They're now using AI to modify TV interviews in order to promote their pseudoscientific beliefs. Tim Mendham from Australian Skeptics says a segment from Australia's Network 10, which featured skeptic Ken McLeod debunking the chemtrail myth, is the latest victim of this trend.
This is a classic case of the awful use of AI. This was a TV show, the morning program that was sort of pretty much a tabloid type thing, mixture of sort of gossip and rumour and advertorials and that sort of thing.
One of those hard-hitting programs Channel 10 are known for.
Yeah, this was probably one of the hardest-hitting programs to have, which was looking at chemtrails, right, which is a fairly out-there theory that the government is dropping all sorts of chemicals or chips or something into the atmosphere from planes to pollute us all or control our brains or whatever, drive us crazy, whatever. It's a strange one because there's a lot of loopholes.
Of course, in reality, it's simply the condensation of water vapour in the air caused by the disturbance of the passing plane.
That's right, and normally sort of titled contrails or condensation trails. People just see these little clouds in the sky following planes, and some people assume it's sort of like crop dusting, that they're dropping all sorts of strange things. Anyway, a story on this Channel 10 program, TV Channel 10 program, was looking at chemtrails, and the opening blurbs describe them as conspiracy theory, allegations, blah, blah, blah. Now, the people who promote chemtrails, and there was one of them on this program, along with a skeptic who was debunking what he was saying, but the people who were in favour of chemtrails weren't too pleased with the fact that this TV station is saying, probably not true. So they took the clip of the host of the program and they dubbed over her words, saying chemtrails are true, chemtrails are affecting us, here's the horror story. Trying to sort of lip sync the lips, which is not always great on AI, but the voices are getting very good these days. So it's a video clip put on Facebook, this phony sort of dialogue, phony voiceover, and then they cut to the chemtrail promoter who was on the program stating his case. Conveniently, they leave off the skeptic who was sort of debunking all those. It's a total fake.
It's about as bad as a fake can get when you think about it. It's so dishonest that I'm surprised it doesn't border on criminal yet. I mean, in a way it does. If Angela Bishop, who's the journalist involved, has been misrepresented, and clearly she has, I think there's a good case for legal action.
Oh, yeah. I mean, the trouble is trying to track down who actually did it is the problem. I mean, there's all sorts of fakes out there. You got sort of noted figures supposedly promoting financial schemes. And I know that the patron of Australian Skeptics, Dick Smith, who's a millionaire, he's had his vision used and a voiceover that sounds remarkably like his real voice, stating this endorsement of this shonky financial scheme that's sort of designed to get people's money in and sort of probably give no return for it. It's happening a lot. It's happening increasingly so. It's dangerous.
It's going to be a great excuse for politicians in the future, but isn't it?
Well, it already is. Yeah, that's not me. That's fake news. That's a fake video. And some of them are totally fake videos. The image is fake and the voiceover, the audio is fake. So this is unfortunately a big danger of things. So therefore, it's hard enough to say to people from a skeptic, don't always believe what you see, look into it closely. But here, if you've got an image of someone who is a genuine image in this case, with a false voice, although it sounds like their voice, stating a case which they never stated, it is an issue. It's a major issue. It's not just a silly little thing. It actually becomes quite serious, and the implications of this are huge. It's certainly one of the dangers of AI, that these things can happen. This should go under existing consumer affairs laws: libel, slander, misuse of information, image theft, it's data theft, it's all sorts of things. So this one should be already available if they bother to follow up on it, and that's the problem.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.